Oops, that's not right. Well, there it is. Sorry, that looks different on the screen here. Okay. When ecologists go out and want to study ecological communities, in the back of their heads, the places they like to go are places with lots of native fauna, lots of native flora, off the beaten trail, places kind of like this, where I came to do my postdoc with Jim a long time ago. But one day you kind of wake up, and you look around you, and all of a sudden your world is very different, okay? It's like, yeah, you can go out here in the agriculture regions of the Corn Belt of North America, and you can find little forest remnants, you can find some little shred of prairie left, but there's no way you can delude yourself you're studying any kind of a natural community anymore. 85% of the land cover in the Corn Belt is dominated by row crop agriculture. The other major land influence that you see out there is urban areas. This actually isn't a picture of a lichen, this is an aerial view of Champaign, and if you ever want to come visit me, the star is my house. So basically, the two major influences in the places I live are urban, like this, and as you can see, the cornfields come right up to the edge of town, and agriculture. And when you think about it, most of the world is dominated by human influences like this. So what I'm going to just make a point of now, and just a few quick examples from the agriculture Midwest, projects that were done that I either supervise with students or people that I mentor and advise, just to make this point that right now, if you're going to study community ecology and you're leaving out the influence of humans on your system, you're kind of like maybe not getting the whole picture. The first case I want to talk about is wetland recreation. I mentor a big group of people that monitors wetlands around the state and products. And one of the things we do also is recreate wetlands as mitigation because it's supposed to be no net loss. Einstein defined insanity one time, you probably have heard this, as doing the same thing over and over and expecting a different result. Well, we do the same thing over and over and keep getting different results. So there's either biologists are insane, or you need a different definition of sanity for physicists and biologists. Okay? We go out, we create wetlands, and the goal of restoration is to try to recreate a community that you're targeting for that area. And there's Einstein's famous equation for wetland restoration. The kind of wetland you get should be related to the size and shape of the wetland, the hydrology you create, the soil fertility and type of soils in that wetland, and the plantings that you do in there to get it started. But that doesn't seem to work out. The restorations that you do often fail to restore a particular wetland type that you were targeting for that area, or the creation and restoration of local conditions alone, it turns out, is just not sufficient for restoring the kind of species community or species composition or community type that you want to create. Jeff Matthews worked in our program here. He just got his PhD a couple years ago, and part of his project was to study these created wetlands all around the state. And he documented all kinds of things that reflect the quality of species composition, native plants up in these wetlands, and regressed them against local conditions, things that were done to create these wetlands, and also the landscape that these wetlands fit in. And what we find out is that local conditions, the things you do to create a wetland, only explain about the same amount of variation that you see in what finally happens as the surrounding landscape influences. In this case, I'm just going to throw out one just quick point here, is that the surrounding landscape, whether it's dominated by urban areas or whether it's dominated by agricultural, affects what kind of wetland, even if you do the same kind of restoration project. If you're closer to urban areas, if you study all these wetlands up in the Chicago area, the closer you are to Chicago, the more non-native species you end up with in your wetland. And in part that's because you have more propagules from non-native species, in part because you have greater disturbance from all the stormwater runoff. If you're in an agricultural area, you get incredible amounts of nutrient flow from the agriculture into your wetlands. This speeds up succession, kind of like really almost doubles the rate of succession in these wetlands, and you end up with fast, rapid dominance by clonal perennials instead of the diversity of annuals that you want. Okay, switching over to mammals. This is part of a PhD project that was done by one of my grad students. We like to look at, we have two species of tree squirrels out there, gray and fox squirrels, and gray squirrels used to be widespread in this area. Now they're mostly found in urban areas and in just big riparian forests along some of the big river systems. Fox squirrels, however, also occur in many of these small towns. and in those large riparian forests, but also are widely distributed around the landscape in little isolated woodlots and other forest remnants. Some of this may be due to history. It turns out, I've never eaten them both, but people tell me that gray squirrels taste a lot better than fox squirrels, so the hunting was targeted towards gray squirrels. And a lot of the gray squirrels that occur in urban areas are introduced populations that once they're extirpated, like the ones in Champaign-Urbana, which is full of gray squirrels now, were introduced there in 1903 after they were wiped out from the whole region there. But why haven't gray squirrels spread out to all the surrounding woodlots and stuff around these areas? It's like there could be a couple of things. Maybe they're outcompeted by the fox squirrels. The fox squirrels are bigger, maybe they're more aggressive. Maybe the habitat has changed and degraded so that the gray squirrels can no longer live there. But in fact, what it turns out is that humans have dominated this system so much that they've really isolated these forest remnants. They've created a matrix in between all these forest remnants that's very open, the agriculture, and is harvested to bareness for good parts of the years. And fox squirrels and gray squirrels just have different behaviors in terms of their dispersal. This is only part of Dan's project here. We did some introductions of grays and foxes into woodlots, and we found that if you introduce grays into these woodlots, they can live there and reproduce there. So it's not that the habitat is degraded, and they're not outcompeted by the fox squirrels that are living there. What happens is, if you take radio-collared juvenile female squirrels, you introduce them into a tree line that's bad habitat, and then you wait and see what happens. You do that with both gray and foxes. The gray squirrels take a lot longer to leave that tree line, which is uninhabitable, than the fox squirrel, so they have a lesser propensity to disperse. And when they start moving around the landscape and you add up the area that they visit a lot less area than the fox squirrels do. Their ability and willingness to move around in this agricultural landscape is much less, and therefore they just don't occur in these isolated forests anymore. Another example, a student whose committee I was on studied the spatial ecology of coyotes and red foxes. As you know, a lot of carnivores interact with each other in negative ways, kind of intra-guild killing, if you will. As coyotes have increased since the 1960s or so in these rural areas in the agricultural region, red foxes have declined. And telemetry studies done by Todd have shown that there's seasonal changes in their habitat use, but the picture here, without going into all that, is that the red foxes kind of avoid the areas where the coyotes are dominating their habitat. And this is particularly important in the winter and stuff when the crops are all down. Basically, at that time, the foxes have moved into town. Foxes are now common in the suburban and residential areas and in the abandoned industrial areas in town. And basically, outside of town, in rural areas, when the crops are down, the foxes are more associated with the actual farmsteads and the roadside habitats, where the coyotes are less done. And occur less. And if you know anything about coyotes and farmers in the winter, when the crops are down and the farmers are bored, they go out on the weekend and shoot coyotes. So basically, we have an interaction here that involves humans. This just goes to show you that in town, foxes, the main thing that kills foxes is predation by coyotes. In the rural areas, is predation by coyotes. In town, every 2 to 3 years is a mange outbreak, but predation by coyotes is not one of the important things. One of my students, two of my students now are working on American mink as our focal subject here. The mink, we're trying to study the habitat use and activity patterns and foraging areas of mink. And obviously the things you do is you embed them in a community. Here you have one of their primary prey, muskrats, another primary prey, crayfish, and coyotes actually find out areas of intense coyote activity, mink avoid those. And if you go out and you play coyote calls and put urine and stuff, the mink move out. They don't like the coyotes. Coyotes kill them sometimes. But if you just do that and you don't include the human impacts on the system, again, you're missing the picture. Because as I just said, humans influence the distribution of the coyotes in a variety of ways. And we know from some other studies of occupancy of these riparian habitats that muskrats actually are more common in areas closer to the headwaters in urban areas. That's because the urban runoff maintains base flow during dry times of the year. It makes good habitat for muskrats. And we don't know what the impact is on the crayfish. We've got studies going on this summer to try to look at the effects of human interactions on these riparian areas, on the distributions of their prey. But without including that human component, if we just want to study the natural quote-unquote system, we would miss the big story. All right, Sharuk standing up. I actually had a couple other bird examples. I could have gone into my time, but I didn't practice it. And also, it's not just mammals. I know I have one student who worked on riparian forest bird communities, and what she found out is it's not just the structure and size and shape of the riparian forest, but the proximity to urban areas that is a big influence on the relative proportions of bird species there. And we have some projects going up in the Chicago area about trains, and basically that railroad infrastructure, even though it's got scrubby habitat along it, lots of birds use those areas. It's not just negative or wasted, and the bird communities of the urban areas, which is a human-dominated habitat to start with, is also primarily affected. About 20 or 30 of those species wouldn't occur there if it wasn't for some of these little human infrastructure effects of the scrubby stuff that is often considered waste habitat along these railroad rights-of-ways and stuff. So the bottom line here is obvious and simple. The little take-home message I just want you to do here is that in the modern world, most of the world has this pervasive influence of humans in it. Okay? And if you're out there trying to study community ecology and you're trying to ignore that and study your natural system, in most of the world, you're probably not getting the whole picture. And you really start needing to include humans in all your little box and arrow diagrams about interactions of species. Whoops, I lost my last slide there. Damn it, that was my thank you. It went away. Anyway, I had a thank you slide to Jim and Ashton, and it didn't show up. Thank you.